Assalamualaikum and good morning to our lecturer, Dr. Shahrul and all my good friends. We are from Group 1 in 3 BMD/1. Want to present about our project presentation in CNC technologies. This is our group members. First, we have Nur MAHIRAH. Then, we have DAMIA Shahira. Next, we have MAHFIZ. And then, it's me, BAZIL Suhaimi. And lastly, we have HAMIZAN.
Assalamualaikum. My name is Nur MAHIRAH and I'm gonna talk about introduction, objective and background. For the introduction, CNC milling, a computer numerical control milling, is a machining process which employs computerized control and rotating multi-point cutting tools to progressively remove material from the workpiece and produce a custom design part or product. This process is suitable for machining a wide range of material such as metal, plastic, glass and wood, and producing a variety of custom design part and products. For the objective, we can see that we can create a practical CNC model of the milling process, write code and simulate the design on a CNC computer using CNC programming coding, identify the basic cutting instrument used in the milling process, capable of customizing machine software, and capable of developing a program, altering and running. Okay, for the background, CNC machining used a machining technique that was developed in the 18th century. In fact, the first turning the machine with a metal frame was invented in 1751. The first of a long series of machines aiming to create more precise operations, mechanical than are possible by handcraft techniques. This marked the beginning of industrialization. By contrast, the programs for CNC machines are fed to computers through small keyboards. CNC programming is retained in the computer's memory. The code itself is written and edited by programmers. Therefore, CNC systems offer far more expensive computational capacity.
Hello, my name is MAHFIZ. I want to explain about methodology. There are 4 processes in this process. First of all, design, generate, set up and run. In design, we using a CAD model, which is we use SolidWorks in 3D modeling, and then we generate the CNC code by using the SolidWorks, and then we set up the CNC code and renew the CNC code by using simulation in milling, and then we run the CNC code in the main milling machine, execute the milling machine process operation by using the CNC code. Thank you.
Next step is set up CNC machine. To start the machining process, we have to transfer CNC coding that we have generated from numeric software to CNC milling machine DMU60 Evo by using the flash drive. Then we have to recheck our coding with our instructor, and then we have to change the CNC coding based on CNC milling machine in case if there is some error with our coding, we have to change CNC coding and tool size based on the CNC milling machine DMU60 Evo. Lastly, execute milling process. Before we start machining, we have to change the tool as shown as in photo. This is two of the process that we have go through for our CNC milling project, which is roughing process and also drilling process, and there is another one which is pocketing.
Next, we have a result from our simulation. After we do a coding in CNC Sinotrain, we have a result from this simulation. We have a top view from the simulation, and then we have a front view from the simulation, and then this is a side view from our simulation, and lastly we can see there's a isometric view from our simulation. After finish this simulation at Sinotrain, we will continue our product to prepare the coding at the monitor machine CNC.
Next slide is machining result. As you can see in this slide, this is our product after all process machining that have been completed. The left side pictures of this slide is our top view of the product, and the right side picture of this slide is front view. Next slide is also the result of our machining. The left picture of this slide is side view, and the right picture of this slide is isometric view. All this picture below shows the final product after finish the machining process. The final product should be clean after machining, and then we doing a finishing with rubbing at the side and angle of the product using a flat chisel. This process will make sure that the final product performing a great looking from many side or angle. Next slide is discussion. The CNC milling process took about 1 hour 7 minutes to complete. Data that we have gathered from Sinotrain software shows that it will be completed in 5 hours. Hence, we decided to increase the spindle speed. To decrease the time taken, we learned that the simulation in Sinotrain is not as accurate as the machining process. There are some parts that have overcut during the simulation. Therefore, we have to change the simpler coding in order to machine our product. There are also chips created due to the spindle speed. We have to ensure every edges are clean on every machining process.
In a nutshell, throughout this CNC project, we are able to design and write code of the CNC milling machine project. We believe CNC machines have many benefits for manufacturing. This is because CNC machines have high accuracy to produce complex shapes with multi-point cutting tool very easily. Therefore, we will not get any error in measuring object. By using Sinotrain software, we can avoid higher cost on defect product as we get to simulate machining process before production. By using the Sinotrain software, we can avoid higher cost on defects product as we get to simulate machining process before production. This proves that CNC machining offers a reliable solution for rapidly manufacturing the parts.